Good morning. Hi, I'm Nate. Thanks for coming to my talk. I want to talk to you today about generating tarot cards with Python. This is a project I undertook to teach myself stuff about image processing because I was terrified of image processing. In case you were at PyDX last year, you might have saw my talk about poetry. And I really like generating poetry with Python because text is easy and fun. It's just characters. It's really easy to move those around. Pixels are much scarier. So I did this to challenge myself, and it was really fun. And today I'm going to kind of teach you the stuff that I learned in the hopes that if you want to do a similar thing, this will make it less scary. So we'll be first defining what tarot actually is. I don't assume that you all know. And then go over the project itself, talk about using Flickr, which is one of my favorite things. Spend a lot of our time talking about how to process images with a library called Pillow. Talk about how the tarot cards are actually generated, and then finally the lessons I learned from doing this. So what is tarot? These are tarot cards. Tarot cards come in a deck of 78. And those 78 cards are split into what's called the minor arcana and the major arcana. So the minor arcana consists of 4 suits with 13 cards each, and you can think of them a lot like, I always mess this up because I never use normal playing cards for anything, but like hearts and diamonds and spades and clubs, is that right? So it's much more exciting in tarot cards. We have swords and wands, and we have cups, and we have pentacles. Then there's the major arcana, which is a set of cards that have names. They're fancy and very dramatic, like the Tower, the Moon, the Magician. And these were playing cards for about 300 years in Europe. People played very complicated games with these cards. I tried to learn one of them on Wikipedia. It was confusing and full of really amusing terminology. It's much harder than Settlers of Catan. Apparently this also confused some English-speaking people towards the end of these 300 years who found these cards and they were like, hey, instead of playing games, we're going to do some divination with these. That sounds really cool. And so that kind of led to this tradition in English-speaking countries of using tarot for divination. So some of you are like, whoa, this is a programming conference. I'm not into that divinatory stuff. You might be expressing some skepticism or doubt. But for me, divination is not like some supernatural thing. I really like things like tarot because what it does for you is it helps you make decisions. It helps guide you. It helps you reflect and do introspection. Say you're trying to put on a big event, or you're processing something that's happened in your life, whether it's good or bad. By introducing random stimulus, these cards that have meanings associated with them, we can kind of observe ourselves and see how we react to those cards, and see how they make us feel. And then maybe that will help us make decisions and move forward with our lives. So that's all this stuff is for me. I find it inspiring. It helps me creatively, and so I really wanted, because I'm lazy, to be able to do this on Twitter. Instead of reaching over to my tarot deck each morning and flipping cards over. I'm really into randomness. I think it's really interesting and important. Again, if you saw my talk last year, you know that this is my jam. I love tarot cards, but the most kind of common deck that you see is called the Waite Smith deck, and that's what these cards are from that we looked at. We've had this deck for over 100 years, and there's a lot of other decks out there. There's myriad decks. People make their own decks all the time. But since, for me, tarot is all about probing the unconscious and being exposed to random things, I wanted to take that concept a little bit further and actually have the cards themselves be randomly generated. And all the better if they're inspired by their actual meaning. So, of course, I turned to the internet, my eternal font of randomness. And the end result of that, all those desires, is a Twitter bot called AutoTarot. And it's pretty simple. It sits on Twitter. You can ask it for a card. It picks a random one. And for that card, it looks at a list of keywords that are related to that card's meaning, searches Flickr for one of those keywords, takes an image, crops it, filters it, glitches it until it's unrecognizable, puts the title on it, and then it tweets it back out. So you can follow it if you want. I think it's a delightful little buddy. It only tweets like 4 times a day or something like that. It's not very noisy. And here are some examples of things that it's generated. Sorry the pictures are small. I wasn't sure what resolution I would be dealing with. So I like this one a lot. It's a hermit card. It's a picture of a shed that looks kind of spooky and in the woods. King of Pentacles. By the way, the VHS font that I found online is like my favorite new font ever. This 10 of Cups. It doesn't say nihilism on that sign, but I thought it kind of looks like nihilism, which is delightful. 3 of Cups. And 3 of Wands. So all of these images came from Flickr. Now they were all randomly processed. They were filtered based on the general sentiment of the card, positive, neutral, negative, and then the title is placed on them randomly. Oh, let's go more. Queen of Swords. So this all starts with a class in Python, the tarot card class. And the class tracks the name of a card, a list of search terms that are relevant to its meaning. Me and a glass of whiskey sat and typed up all 78 cards, researched each one, read all the meanings for each card, extracted keywords, made a list. Then I manually went and, given those meanings, assigned a positive, neutral, or negative sentiment to each one. And the class also, when you create an instance of a tarot card, it might get inverted. So there's a concept with tarot cards. Usually when you're using tarot cards, you do what's called a spread. So you lay cards out in a certain pattern, and the placement of cards in that pattern is meaningful. Sometimes cards end up upside down. That's an inverted card. It kind of flips the meaning of that card. So when you instantiate this class, there's a random chance that it might come out inverted. So we start by picking a random one of these, and then everything else that happens is kind of influenced by an instance of this class. So you can see this example of the 9 of Cups here. The sentiment is being set to an instance of a sentiment class, because the sentiment also needs to track state, whether it's been inverted or not, along with its card that it belongs to. So I wanted to take a moment and just kind of sing an ode to Flickr. Flickr has been trucking since 2004. That's a really long time in internet years. Flickr is essentially like 1,000 years old. But somehow, in this age of slash and burn startups, Flickr's still around. Its API is free, it's stable, it's well documented. The search functionality is really nuanced. You can do lots of useful things with it. You can it even has support for searching by like really specific licensing terms. So you can only search for like images with a certain Creative Commons license. There's a Python library called Flickr API. Works very well. So let's just all together pray that Yahoo does not alter Flickr any further. Yahoo has a not so good track record of destroying the things that it owns. So yeah, I'm really bullish on Flickr. So this is some sample code of searching Flickr. So here I'm just instantiating a death card. It's my favorite card. And we get a search term out of the card. So a search term is an attribute that returns a random keyword out of the keyword list for a given card. So we search Flickr. And when you're using the search method in Flickr API, if you just use the text keyword argument, that will search the title of photos, the description of photos, and the tags of the photos. So we're just going to search for, make a big search, and then pick a random result out of that. This next part is a little bit frustrating. We construct a URL, so we can actually download that photo into memory. And you have to first pick a size of the photo that you want, which is another API call. For some reason, the sizes don't come in the standard photo payload. And then you extract a URL through this confusing nesting of parameters, but it's not so bad. So once we have our URL, then here I'm just using Python's built-in URL open to make a readable photo image in memory. So that's how this, so we make a card, we search Flickr, now we have an image, now we want to do terrible, beautiful things to that image. So the bulk of this talk from this point on is going to be discussing a library called Pillow. So Pillow is actually a fork of another library called Pill, the Python image library. And this was not for fun. Pill had lots of bug fixes piling up. It was getting hard to install, and it just wasn't really being maintained. So some people, to whom I am very grateful, forked Pill, and they called this new library Pillow, which just sounds a lot nicer too. Like you got pills and you got pillows. So Pillow's much nicer, easier to install, full of bug fixes. But because it's a fork, when you're actually working with it in your code, you still refer to it as Pill. So when you're importing it, you import PIL. So I love this library. It does really, really cool things, but its organization is a little bit confusing. I'm not harshing on it. I think it's an old open source project. And as open source projects go on, people add things, and there's not always maybe the level of consistency that you might want. So we're going to go through a couple different tools that Pillow provides, look at how to use each one. They're all different. That's why I'm teaching you about them, because I found them very confusing. And they all do different things. So this is our base image. If you have not seen Deep Space Nine, these are two of my favorite characters from that show, Quark and Odo. I, along with many people, like to think that they're deeply, deeply in love with each other. It's just an unrequited love that we don't really get in the show. So me and people who believe similarly, we all call them Quoto. They're a unit. So this is a picture of Quoto, and we're going to be manipulating this picture and seeing what happens to it. So everything with Pillow starts with the image class. So we import image from Pill, and we call image.open, and we assign the result to im, and that is an instance of the image class now. You can't do a ton with just a basic image, but we can do things like cropping. So we can first check the size of the image and get that back in x or in width and height. We can check the mode. Mode is going to come up a little bit in this talk. So if you're not familiar with image modes, the mode of an image refers to what type of information is stored in each pixel of a picture. So a picture is made up of tons of pixels. They're arranged in a grid, and each one of those pixels has a little bit of information. So in some images, their pixels hold three things: the amount of red in that pixel, the amount of green, and the amount of blue. There's other modes, like RGBA, which is the same as RGB, but there's also this fourth element of transparency, otherwise known as alpha. So this image is RGB, so there's no transparency. Every pixel just has these three values, and we might need to convert it a couple times to do certain operations, which we'll see. So to do a thing like cropping, we first make what's called a box. A box is a tuple of 4 numbers, and I've labeled them, hopefully, helpfully, as x1, x2, y1, and y2. So every image in Pillow has, it's a big grid of pixels, and those pixels are numbered, and they start in the upper left for you as 0, 0, and we kind of count down from there. So we're making a box that starts at 100 in the x coordinates, goes to 100. It goes for 100 pixels, and we do the same thing, but 400 pixels in y. You'll note that that's out of bounds. Our image is only 326 pixels high, so we'll see what Pillow does when we give it input like that. So we call crop, and we get back a new instance of the image class. This is a really nice property in Pillow. Pretty much everything just gives you back a brand new instance of image, and you can just keep doing stuff to it, or you can save it. So we've saved it to Quoto cropped, and it looks like that. So like I said, we were out of bounds, and Pillow just helpfully added this black bar, which you can't really see on the screen, but there's like a margin at the bottom. So if you have watched any Star Trek or really any TV show, there's always a moment where they have some like image, and somebody very grimly looks at that image and they go enhance, and they like hit a button, and then like we zoom in like unrealistically really close, and we see these details that we couldn't see before. So it seemed fitting that the first module in Pillow that we talk about is called image enhance. It doesn't do that because you can't do that. Um, instead, we do things like manipulate the brightness and the contrast of an image. So if you've ever wanted to make your own Instagram filters, you can use this. So now our code sample is a little bit more complicated. We're importing image as well as image enhance. We still open our base image just like before. And now we're creating what are called enhancers. So an enhancer is an object that knows about some image. You can see we're creating a brightness enhancer, and we're passing it our image instance. And once we have that enhancer, we can call its enhance method and pass it a number. So that number is like you can go less than 1, so like a decimal between 0 and 1, to kind of de-enhance, reduce whatever the effect is. Or you can go, 1 point something all the way up to like a factor of 3 to enhance. So we're going to increase the brightness a bunch. We're going to save the result of this, which is, you guessed it, an image object. We're going to make another enhancer using that output. And that one is going to adjust the contrast of our image. So we do a factor of 3 there as well. So we've taken our base image, we made it brighter, and we increased the contrast. So let's save that and look at it. Beautiful. Not exactly a super zoom into the image, but I like it. The other things that you can do with that module, you can mess with the color balance and the sharpness of the image. I like thinking of all of these 4 things as knobs on like an old TV set, if you've seen one of those. So the next module that we'll talk about is called image filter. So here, if you've ever used Photoshop or the GIMP, these are the kind of operations that you'll see like in the filters menu. And we apply them in a very different way than the enhance class, because that's how Pillow rolls. So you can do fun stuff. You can blur the image, you can sharpen it, you can detect the edges in the image and just throw everything else away. And you can emboss the image. If you're not familiar with embossing, that's when you have like a raised image. So say like you stamp a piece of metal, and then you pick that up, and it's this raised kind of bumpy image. So we're gonna find some edges and emboss them. I want like a plaque, like a beautiful Quoto plaque. So we're gonna import, this time, image as usual, an image filter. Filters are stored as constants in the image filter module. So we, just for convenience, I'm assigning those to easier to type variables, find edges, and emboss. And once we have those filters, we pass them to the filter method on the image object. This is a little bit nicer than enhance because we can chain these. Since the output of im.filter is another image, we can just call .filter again. So we find the edges, and then we emboss. And we end up with this beautiful plaque. I would put that on a building. So you can chain these to your heart's content. And you can combine all of these things for extra fun. There's also delightful filters like edge enhance more and sharpen more, which do even more of those things. And yeah, this one I end up using a lot. So ImageOps, yet another module that has a grab bag of things that it can do. We call it in yet another way. The only thing that really groups the things in ImageOps together is that they're all really common operations that you'll see with image processing. So again, import ImageOps, open our base image. And this time, we're calling functions defined in the ImageOps module. So we're going to do 3 things. First, we mirror the image, so that's flipping it horizontally. And then we invert the colors. So that's a process of, for each pixel, essentially like going to the opposite end of the color spectrum. So if it was black, then it becomes white. And then finally, we posterize, which is one of my favorite things. So posterizing, if you're not familiar, is the process of going to each pixel and then saying, I'm going to just throw away data from that pixel. So the number that I'm specifying there, too, is the number of bits that I want to keep. And so each of those pixels in this image has 8 bits of color information. And I'm going to throw away 6 of them. So I'm just basically making a crappier image. And I love that effect, because it looks like it's from a DOS game or something. So I've done those 3 things, and I've kind of nested the results and ended up with this final posterized variable. Save that. we get this work of art. So yeah. So hopefully you can see the effect of each one of those operations. We mirrored the image, so they're in the reverse order now. We inverted the colors to get this weird like blue and white palette, and then we just threw a bunch of colors away to end up with these kind of big flat planes of color. This is the most complex thing in Pillow that we'll be talking about. So text placement. When I went to learn how to do this, I got very incredulous because I'm used to going into Photoshop or the GIMP, and you click the brush, you paint some stuff. You click the T, type some text. Very easy to put text on an image. But when you're doing it programmatically like this, it's a little bit more involved because computers don't know about text when it comes to images. They know how to paint pixels on a screen. And at the end of the day, when you're creating an image with text, you're just painting that text on there. And you use a font file to tell the computer, like, hey, I want you to paint, I'm going to ask you to paint this thing. It's called C. It's a letter. Maybe you've heard of letters, computer. I don't know. But here's how to draw a C. It's in this font file. So we have to tell Pillow that we're going to draw things. We need to tell it that we're going to draw text and give it a font file so that it knows how to draw those letters. And then we're going to actually create the text, and then we're going to slap it onto our base image. So going line by line, I import a bunch of stuff now. I import ImageOps just to convert the base image to grayscale. It'll make the text a little bit easier to see. It's also prettier. And I also import image draw and image font. I set up some fills. So a fill is a set of 4 numbers, which represents color and transparency levels, or opacity levels. Opacity is how opaque a thing is. Transparency is how transparent. 2 sides of the same coin. So the first fill is a transparent fill. The first 3 numbers are red, green, and blue values, and the last number is how opaque it is. So since I've set 0 for the 4th number, the color is actually irrelevant. This is just transparent. So when I'm drawing and I tell Pillow, like, hey, I want you to fill this drawing with some color, and I give it this, it's just going to make it transparent. The next fill, which we'll be using when we actually draw text, is just opaque white. So here all the values are maxed out to 255, which is the highest number that we're going to use in these values. So it's olive red, olive green, olive blue, which makes white, and then all opaque. So we make a brand new image is the very first step in doing text by calling image.new. We have to specify the mode. And you'll note here, instead of RGB, we're doing RGBA because we want transparency. You'll also note up here, at the end of this line, I converted our base image to be RGBA. I added some additional information to every one of those pixels to keep track of transparency. So this new image has RGBA mode. It's going to have the exact same dimensions as our base image. I'm passing image im.size as the second argument. And then the third argument is the fill. So now we're using that transparent fill. So we just made a transparent square. We're going to draw stuff on that, and then we're going to layer it on top of our base image. So it has to be transparent, so when we layer it, we can still see the base image. The next thing that we create is called a draw object. And a draw object you can think of it as a Pillow image, but it has some additional capabilities to draw lines and shapes and things like that. And then finally, we create a font object. So this represents a font file. TrueType is a kind of font. It's a font format. So I downloaded this from Google Fonts. It's called Tangerine. So I open it with the TrueType method, and I give it a size. So 120 here is, you can think of it like point size when you're setting up like font point size in Word or something. And then we actually draw some text. So we're using the draw object, which is our image with enhanced drawing capabilities. And we say we want to start drawing at 0, 0, so the top left corner. And we want to write out the text of the lovers. And if you're wondering why it's that text, well, this is a talk about tarot cards. And there's a card called the Lovers. And since Quoto is the purest expression of love, we're going to make it a Lovers card. So we say what font to use. So now the draw object knows, like, oh, okay, well, you want to make a capital T. I'm going to look that up in the font file, or the font object, and figure out how to actually draw those pixels. And then we specify a fill, and that's where we use our opaque white. So now we have a transparent box. It's got some text in it. The last thing that we do is we merge it with our base image. We use a function called alpha composite in the image module, which takes two images, and it takes the second one, puts it on top of the first one, and the alpha composite gives you a hint that it will pay attention to transparency. So after all of this arduous labor, we have this beautiful Quoto lover's card. So cherish it forever. OK, so there's one more thing that I do with Pillow in Autotaro. It's called pixel sorting. We're not going to go into it today because it's pretty involved. There's a lot of math, and I'm not a big fan of math. And there's a module on PyPI that does it for you. I highly recommend checking it out. This is a screenshot from Sailor Moon that I pixel sorted. You may have heard of Crooked Cosmos, is a cool Twitter bot that pixel sorts, but yeah, you should Google it. So we're gonna tie all of these elements together and walk through the code that actually generates an image from a tarot card, and look at the kinds of operations that I'm doing to come up with the results that I showed in the beginning. So we'll be talking about a function called generate. It takes a tarot card. It returns a pillow image. We start by calling the getPhoto function, which is doing all that Flickr searching stuff. We open it as a pillow image. This next chunk, it's not super critical that we go line for line here, but the point here is what we're ultimately gunning for is what's called a pipeline. We want a series of functions that all take an image and return an image, so that we can call them all just as like a list. Like and the reason that we want to do it that way is because when you're doing image processing or like video rendering, you can do certain optimizations when you have just a bunch of functions that take an image and return an image. Some of the functions that we want to use, though, they take a card and an image. So here I'm just using Python's partial, which is a function that takes a function and an argument, gives you a brand new function that will call the original function with that thing that you passed as the first argument. So we set up a bunch of these functions. We set up these lists of distorts. Each of these is a function that takes an image, does a terrible, beautiful thing to it, and then returns the image back. We shuffle those lists so that we can use them randomly. And then finally, we actually walk through the pipeline. So the order that we go in, we first randomly crop the image. So we crop a card-shaped hole and take that and make a new image out of it. We potentially zoom into it to make it kind of pixelated because I like that effect. There's a random chance that it might not do that. And then we modify the image based on the sentiment of the card. So if it's neutral, we posterize it ever so slightly. If it's positive, we make it brighter and sunnier. And if it's negative, we take either red, green, or blue. We just delete all the pixels of that color, and then we harshly posterize it because we want a scary negative image. Once we've done that, we apply one of our random pre-title distorts, and then we put the title down. That picks a random position, picks a random font size, and then puts that on the card somewhere. We check to see if the card was inverted, and we potentially flip the card. We either mirror it or turn it upside down. And then finally, just for good measure, 2 more random distorts. So this is a list of functions. Each one takes an image and returns an image. So to actually make our image, we loop through that list, calling the functions that we get out of it. So I'm going to eat into question time just a little bit, which I apologize for, but yeah. This is the penultimate slide. So, lessons that I learned. Image processing is not actually that terrifying. If you've watched this talk and still think that, I have failed, and I apologize. So definitely, I'm happy to talk about this stuff if you want to learn more or have any questions. One thing that I learned during this, I was terrified of being sued by an irate Flickr user, but luckily, this Twitter bot qualifies as fair use. So when you're doing art projects and repurposing content from the internet, I highly recommend reading the 4 rules of fair use and analyzing your project and seeing if you actually meet those qualifications. The most important lesson is to test your art projects. I was being very, very bad. I did not write tests for this art project. As a result, I had a bug that infinitely looped and spammed Twitter as fast as it could, until I tweeted 300 of the same images, got cut off from the Twitter API for a day, and I was deeply, deeply humiliated. Nobody seemed to be that angry at me. But then I learned how to delete statuses with the Twitter API because I had to write a script to do that. So yeah, test your art projects. Don't test everything, but when you're posting to Twitter, you should, keep an eye on it, write a couple tests for that. A funny thing that I learned is that Twitter is often over capacity. If you've used Twitter for a long time, you can remember the days when you'd go to Twitter and you just got the fail whale picture. Twitter totally still does that. They hide it from you in the GUI, but when you're using the API, you will get overcapacity errors. So just code defensively. Be aware that when you call out to Twitter, it might just fail. So that's it. Thank you very much for listening. So you can find the bot there. You can find me there. The code is up. It's called random Waite. And I wanted to thank all of these things down here. They all helped me. So yes, thank you.